Hello, everyone, and welcome to this Telit Cinterion webinar, In-Factory SIM Provisioning, Part 2, a Secure iSIM Technology. I'm Amanda Flink, the Head of Global Events here at Telit Cinterion, and I will be moderating today's event. To explain this topic today, I am pleased to be joined by Emily Yua, Product Manager, SIM Technologies at Telit Cinterion. Now, just before I hand it over to Emily to start the presentation, I have just a few quick reminders. I would like to remind our audience that we will have time to answer some questions at the end of our presentation today. You can simply submit a question by posting in the questions box, which should be located near the bottom of your screen. Also, please be sure to check out the resources section. There you can find today's slide deck, a few other resources about this topic. And if you missed part 1 of this webinar, that link can also be found in the resources section there. And with that, Emily, I will hand it over to you to start our presentation today.
Yep. Thank you, Amanda. Hello, everybody. So today I'm going to talk about in-factory SIM provisioning and most particularly on iSIM technology. So what to expect from the webinar today? So first, I will give some generic information about iSIM technology, what it is, and then we will see why and how it impacts the production process. Then I will give you some insights about the two-step personalization process defined by the GSMA. We will also discuss the challenges that can be faced by the factory with this new technology. And then we will discuss a bit about the future and yes, what is iSIM future. So let's get started from the beginning. So what is an iSIM? iSIM stands for Integrated SIM, and it refers to the implementation of a SIM in a tamper-resistant element, also called TRE, that is integrated into a system on chip. It can be seen as a very small SIM form factor, the smallest one. iSIM can be either a UICC, meaning that it will host a single MNO profile, but it can also be an eUICC, meaning that it will support several profiles and it will be manageable with a remote SIM provisioning platform. iSIM offers the same level of security than a physical SIM, or you could even hear that iSIM is more secure because there is no way to take out the part. It's not physical component, so you could also hear that it's more secure. So obviously iSIM has a very small dimension and it does not consume lots of power. So it can be used in new small devices like asset trackers, for example. Additionally, iSIM lightens the bill of material and it simplifies the logistics compared to the one required in case physical SIMs are used. So this is quite generic. Now let's start looking at the details. What is inside eSIM? So to get an active iSIM, let's say, a connected iSIM, you will need the secured hardware, obviously. But then inside this hardware, it will be required to load a SIM operating system, then some security credentials, and then a connectivity profile to get connectivity. The operating system is the same for all iSIM, but the credentials are unique, and the connectivity profiles are also unique per chipset. The hardware is provided by the system of chip manufacturer. The SIM operating system is provided by the SIM supplier, as well as the UICC OS credentials, and the connectivity profile is provided by the MNO. So now we are talking about connectivity profile. So let's compare a monoprofile iSIM to an iEUICC. So as we mentioned before, iSIM cannot be easily taken away from a device, which is good, but then it explains also why the remote SIM provisioning technology and EUICC is very appropriate for iSIM, since it will give the opportunity to change the MNO profile remotely. So this sounds a better approach to us, and we also think that the new standard, the new remote SIM provisioning standard, eSIM for IoT, like SGP32, will be the most interesting choice for the future IoT products. So on the right, we have this small picture showing that we will have an EUICC, so an iSIM with the EUICC capability, that will be able to download profiles from a DP+ through the IPA that is standardized by the GSMA SGP32. And the device will be remotely manageable by an EIM platform, again as specified in the SGP32 standard. So from now on, we will focus on EUICC and not monoprofile SIM. So in this case, what about the certification? An iSIM should follow the same certification process than a physical SIM. So the GSMA has defined a strong compliance process. Several steps are required to prove compliance and to be part, let's say, of the remote SIM provisioning ecosystem to be eligible to certificates delivered by the GSMA. So the card, the iSIM, will need to prove its functional interoperability. It should also demonstrate its security. There are two parts. There is a security by design. So here there are some requirements, like the iSIM hardware must be common criteria certified, and the minimum standard is EAL4+. And then there will be there is also a requirement for the security in production. So the site producing the card should be audited and validated by SAS UP. So SAS is from the GSMA. And then once all aspects are validated, then the compliance can be achieved. Okay, now let's look at the production processes. How does iSIM impact the IoT production processes? We can say that physical SIMs are ready to use. They can be inserted in a device and they could work. I mean, maybe an MNO profile should be loaded, but in general, the component at least can be plugged and it should work. In case of iSIM, it will be a bit different because, as we saw at the beginning, an operating system and some specific credential will have to be loaded on the iSIM. So this is different compared to physical SIM. So let's look at the different steps. The module or device manufacturer will first order chipsets to the SoC manufacturer and will receive them. In case of physical SIM, the module or device vendor also needs to order SIMs. So this can be done simultaneously with the order of chipset or not, but well, SIMs have to be ordered, they will be received, and then they will be inserted into the device. So this requires that the module or device vendor manages a stock of SIM. In case of iSIM, the process is different. The module or device vendor will not order SIM, obviously, but instead he should order, let's call them iSIM perso, to the SIM vendor. The SIM vendor should provide the secured SIM operating system that will be the same for all iSIM, but it should also provide some personalized data, and those data should be prepared for a given chipset, and we are going to display this in the next step. This last step of loading the personalization data into the iSIM is defined in the two-step perso from GSMA that we will explore right now. Once this is completed, the last step will be the loading of the MVNO profile. So let's look at the two-step perso defined by the GSMA. So thanks to this process, no GSMA security certification will be required for the module or device maker. So it simplifies things for them. But how does it work? So here we can look at two entities, the SoC manufacturer and, on the other hand, the integrated SIM vendor. The SoC manufacturer has to generate some hardware security credential, and he has to insert them into the system of chip. This should be done in a site audited by the security accreditation scheme from the GSMA. So this site should be SASUP to SC. So this is the first step of the process. The integrated SIM vendor should generate securely UICC credentials. Then those credentials should be prepared for a given chipset so that they can be loaded only on this chipset. This is a security measure to make sure that really those credentials are prepared and are prepared for a given iSIM and for a given SoC and will not be used in any other component. So this second step is the perso UICC, and this generation of credential and this securing also of those credentials should be done in a site that is SASUP to UICC. So this relates to the integrated SIM vendor. Then the last step will be the loading of those secured EUICC credentials into the SoC, and this is done in the module or device maker factory. So again, thanks to this process, the security is ensured, but there is no impact for the module or device maker. Okay, so this is required to load the secured credential into the iSIM. And as we saw before, the last step to get a connected iSIM is the loading of the MVNO profile. So for this, we have several options. Actually, those options are the same than in case of physical SIM, and they were presented in our last webinar about in-factory profile provisioning. So the profile could be installed over the air thanks to a bootstrap, in case the bootstrap was part of the operating system, for example. Or the profile could be loaded in factory thanks to a local LPA or IPA client following an online process. Or in the future, we could see some provisioning in factory using the new SGP41 standard when the factory could be offline. Again, I invite you to check our last presentation on the topic to get more details. Okay, now, so we saw what were the requirements to prepare an iSIM, but now let's try to see what are the impacts for the factories in practice. First, the factory should define an ordering process, because the factory could decide to order all personalized data at the same time that it ordered the chipset, but it could also decide to order them depending on the production, only when the perso data are required. So this is the first thing that has to be defined. Then we saw that the SIM operating system and the credentials must be loaded on the iSIM. This is done thanks to a tool that is delivered by the SOC supplier. It's not a standardized tool. So the factory has to understand how this tool works, and the factory has to integrate this tool in his production chain. It also means that the factory should adapt its process to use this tool. Like, for example, when the device is manufactured, the production line should read chipset ID and then input it into the loading tool. And as a result, the loading tool will deliver the appropriate perso data that should then be loaded into the iSIM. The factory should also consider that some time will be required for the loading of the data inside the iSIM. So we are not talking about minutes, but still it can impact the line. And then we can also consider that the setup can be more complex in case several factories are involved. The overall architecture should be defined. In case several factories are involved, will they all keep the perso data, or will there be a central server managing those data? So those questions will have to be answered by the factory. And we can also note that the complexity will be increased in case there are several SOC manufacturers, because as mentioned before, the tool used to load the data is not standardized, so it means different tools that should be used. And it could also be more complex in case several SIM suppliers are involved, because the right SIM supplier has to be contacted, let's say, for a given product. And we can also mention that the validation of the product could also be a bit more complex. If we want to test the device in case there is a problem, maybe we will not be sure if the problem is coming from the SOC or from the SIM-OS, etc. So more actors will be involved. So it could take a bit more time. So when can we expect more iSIM in IoT devices? So in fact, iSIM are already in use in many IoT devices, but those iSIM are hosting a monoprofile SIM. It's a unique connectivity that cannot be changed. iSIM could extend further as an EUICC once more chipsets are certified, because this is a key for the MVNO adoption. The MVNO will only accept to load this profile onto the iSIM if it proves that it's secure enough. Then we will need production sites to be two-step perso certified, because this process that I presented before is defined, but not many suppliers are certified today. So we need more actors to prove their compliance. And as indicated, we believe that iSIM will rely on NGP 32, the new standard, and we may need a bit more time to see this standard deployed, even if we will see the first compliant EUICC very soon, but still the entire ecosystem may take a bit more time so that all components are ready for this new standard. And finally, I would like to explain how Telit Cinterion could help you on the topic. So first, we we got some experience on monoprofile iSIM in the past. We had a proprietary iSIM implementation. Then we looked at the monoprofile iSIM. So we built an experience on the topic, and we are always improving this experience. We will also prepare to deliver compliance modules with iSIM enabled. So iSIM enabled means that this complexity that I presented into the factory challenges, this complexity will be taken on our side, and we will deliver iSIM enabled modules. So no extra complexity will be given to the customer, so it will be easier for them. We are also preparing to deliver our own connectivity on iSIM, our next profiles on iSIM. And of course, we will provide our remote SIM provisioning services on iSIM. And right now, we already have tools for the loading of profiles in factory. And we are here to be a trusted advisor to help you to build your product, your current product and your future product. So please do not hesitate to contact us if you need more help on this topic. And I think that concludes my presentation today.
Great. Thanks, Emily. Now, just before we get to the questions, audience, I am going to drop a quick poll on your screen. If you would like to have one of our experts contact you directly, perhaps you have some specific questions that you'd like answered one-on-one, please just respond here on the poll and we will have someone reach out to you. We do have time to answer a few questions. And it looks like we have a handful here, so we will just dive right in. The first one I have says, will it be possible to manage iSIM with existing remote SIM provisioning platforms?
Yeah. Okay, so let's consider here that we are talking about an SGP32 iSIM. So in this case, this iSIM will be manageable with the SGP32 servers, DP+, EIM. There will be no difference compared to an SGP32 eSIM. So it can be good to know, because if a device maker is transitioning from eSIM to iSIM, in terms of remote SIM provisioning, it will be seamless and the same technology can be kept.
Great. Next question, what are the advantages of iSIM for an MVNO?
Yeah, so for an MVNO, I would say that iSIM is one more opportunity to provide connectivity profiles, because as we saw at the beginning, iSIM gives possibility for new types of device, innovative, very small devices. So it's one more opportunity to provide connectivity. So of course, as we saw, the very important requirement is that the iSIM prove its level of security. But once we will have such iSIM on the market, then I would say that for an MVNO, it's really a good opportunity to extend his targets.
Great. And I'm trying hard here to keep us under 30 minutes. So I think I will take just one last question. And this was kind of a good one to wrap up on as well. Question asks, when can we expect the adoption of iSIM in the IoT market?
Yeah, the adoption. So we saw that there are several challenges that will have to be surmounted. The need for certification, the need for the deployment of the standard, etc. But maybe we can refer to some figures from Counterpoint. We recently published some figures, and they claim that iSIM should increase a lot in the 3 next years. And in the long term, like in 2030, it will be a very common form factor. So let's hope that this is true and that iSIM will grow.
Great. Thank you so much. I think that wraps us up today. Audience, again, please be sure to check out the resources section. You can find part 1 of this webinar there. Emily, thank you so much for your time today, and thank you everybody who joined us. Have a good one.
Thank you, Amanda. Thank you all.